Okay, our next panel will discuss one of the things we all have in common, and that comes into play on every flight, every day, an airplane. I'm going to change roles here again, and I'm going to have the privilege of moderating this next panel. Even though commercial airlines have achieved one of the safest records in aviation history, we must still remain vigilant and continue to look for ways to improve the safety record. We must stay ahead of a continuously changing operational environment that may be driven by economic and societal pressures and not safety. Our commitment to safety must remain steadfast to being the highest priority in this industry. The traveling and shipping public have come to expect no less. With new initiatives, like you heard this morning from NextGen, having completed the development phase, new technologies and procedures intended to improve airspace efficiency are now being introduced into operation. New technologies have also provided advanced automation and lightweight materials that are enabling a new generation of aircraft to perform at operational efficiencies never imagined just a few decades ago. In this new generation of aircraft have also come massive amounts of onboard data processing that can be monitored and managed not only for performance improvements, but for safety enhancements as well. Improvements in efficiency support the accountant's bottom line, but what are the new technologies on the horizon to ensure that we continue to maintain and improve safety? That's our bottom line. We have with us today a distinguished panel. From Boeing, Captain Terry McVenes, Director of System Safety and Regulatory Affairs, and certainly no stranger to this audience. From Airbus, Captain Harry Nilson, Executive Operational Advisor to Product Safety and an Experimental Test Pilot. And from Embraer, Captain Nilson Perini, Test Pilot and Air Safety Engineer, and he likes to go by Perini. So these gentlemen will update us on what their organizations are doing along with the regulators to ensure that our safety expectations and that of the flying public are met. So with that, I'm going to start off with Terry. Terry, tell us what's going on at Boeing.
Well, thanks, Chuck. Thanks for inviting me to be a part of this panel, and all of you for coming here. It's always nice to come back for this event every year. I've been doing this a number of years, and it's really nice to be back when I'm sitting on this side of the table instead of Chuck and the rest of the staff's table over there getting ready for this event. So appreciate all the good work that's being done and continues to be done by ALPA. As I was developing some of my thoughts for what I was going to talk about today, I thought about the organizational vision that we have within aviation safety at Boeing, and that is a safe, efficient, and growing air transportation system. So I organized my thoughts kind of around those three adjectives of safe, efficient, and growing. And so I'll talk a little bit about those three areas of areas that we're working on at Boeing in terms of and how it all kind of fits in with some of the safety things that we're working on. So changing things from adjective to noun, talk about safety, our data-driven approach that we use that kind of drives some of the information and the emphasis that we place on different things. In the area of efficiency and technology, some of the research that we're doing to get some advances in efficiency, and then talk about growth in the industry. And I think this is a real good news story that we're all facing, but there are some challenges associated with that growth as well. So from a data perspective, some of you that are involved with the commercial aviation safety team have seen this kind of chart before, where we take a look at accident categories, where, and then based on how things are going in those different categories, where can we get the biggest bang for our buck in terms of emphasis on different safety things. And so what this chart is, it's a series of bar charts looking at where accidents have occurred in different categories from 1993 through 2012, split into 10-year groups, and then move it forward 5 years at a time. So you can see when you do that, are you getting better in these areas, or are you getting worse with time? And so just kind of walking through it, if you look at the very first set of three bars there, you see CFIT. And we heard some of that, a little bit about that this morning. But when you look at the numbers associated with CFIT, you can see the numbers have really come down a lot in recent years. And continuing to move in the right direction. And of course, certain technologies have helped in that area. eGPWS, for example, has been a real benefit to this in getting those numbers down. The next group of bars there, loss of control in flight. While the numbers are coming down, there's still some progress that needs to be made in this area because it still remains pretty high. The next two groups are midair and smoke and fire, very small bars and getting lower. The next one, runway incursions. You can see we're going in the wrong direction there. The number of fatalities associated with runway incursions is growing. And then the last set of three there is runway incursions, which again are fairly minimal. So when we look at the safety dollars we have to invest in our product line, we use this data along with a lot of other data. You can see the areas that we're focusing on there with the black arrows, and that being loss of control in flight and runway excursions. And while it would be really nice to say that you can do some technology to fix these things, these are some really hard ones to fix because it can't just be solved with technology. Certainly fly-by-wire, envelope protection, roll arrows, those sort of things are very helpful in this area, but they're also not a panacea either. There's other things that need to be done. Operational considerations are important, training, are very important. So we're working in all these areas and working with ICAO, other manufacturers, pilot groups around the world to help get some information into their hands to kind of help in these areas, as well as, again, looking at different technology that might be available in them. But these are the two areas from a safety standpoint that are really our focus area: loss of control in flight and runway excursions. When we talk about technology, and I've got to give credit to a colleague of mine at Boeing. He was here a couple of years ago, Mike Carricker, and he talked about the changes in technology that have taken place over time. So I'm stealing a little of his material, but I thought it was a really good message because it puts things into perspective. These are some of the areas that we've seen some big technology changes from the 727 to what we have today in the 787. In the area of auto flight, the 727 has some pretty basic modes on it. Heading hold, altitude hold, and VOR track, and that was about it, right? Today, you got guidance from 50 feet on takeoff right down to rollout. So pretty precise autopilots today. Flight directors weren't coupled to the autopilot. Today, they're fully coupled to the autoflight system. No auto throttles on the 727. Today, auto throttles from toga all the way to flare, so very, very integrated systems. Manual nav tuning on the 727. Today, FMC nav aid tuning with gyros and ring laser gyros and all sorts of things going on there. So quite a bit of change. Some of us are old enough to remember even the coffee grinder ADF systems we use sometimes for tuning our nav aids. So big changes there over the years. In the areas of fuel systems, mechanical engine fuel controls, today we have FADEC with auto light, auto shutdown, auto start, everything's automated today. Flight controls, cables hooked up to actuators, and today closed flight loop systems, flight control systems that have all kinds of alleviations and compensations that are all automatic and the pilot doesn't even know what's going on. Caution warning systems were very distributed in the 727 days. With the 787, we have ICAS. And certainly all the systems on the 727 were pretty much controlled manually, and today our systems are all controlled automatically. And the other little bubble down there is a chalkboard. And I put that on there because with the 727, you could draw out the systems on a chalkboard. Today, you'd have to be kidding yourself if you think you could draw out the systems on a 787, even on a whiteboard. So lots of changes just in the way that we look at technology. One of the areas that we're working on in terms of new things in technology is with our Eco Demonstrator program. We started this back in 2011, and since then we've looked at about 40 different technologies. We started on a 737NG, then a 787, and in April of this year, we launched our Eco Demonstrator 757 program in conjunction with the TUI group out of Germany and NASA. So we're doing some joint things with those two organizations. Really looking at ways that we can improve efficiency, reduce noise, and carbon emissions, because that's really becoming a big deal. The whole carbon emissions thing is really going to impact this industry going forward. And the purpose of doing this on a flying test bed is by doing it in a kind of a flight test mode, we can hopefully get some of these new technologies out to our customers much more quickly and more efficiently than we have in the past. So some of the things we're doing, for example, on the left wing, and this is really cool stuff because we're doing different things on the left wing than the right wing. But we're looking at things that'll help improve the laminar flow over the wing. And we're testing a Kruger shield that goes out to kind of deflect some of the bugs away from the leading edge. So again, keep that laminar flow going across the wing. On the right wing, again, we're looking at some different coatings on the wing that'll actually help the bug residue kind of dissipate. Again, to try to keep that smooth flow going over the remainder part of the wing. We're looking at the vertical tail and doing some active flow control type of things that will maximize some of that aerodynamic efficiency. And we've done some wind tunnel tests in this area, and we actually think that there's a possibility we could get up to 20% increased efficiency on the tail, and then maybe down the road that could lead into smaller tail designs, which would again help in that efficiency, weight, and things like that. So again, very, very interesting program. It's been going on since 2011. We're learning a lot, and some pretty neat stuff that the guys that are flying this, I tell them they got the best job in the world because they're doing some pretty neat stuff with, like I say, different things on different parts of the wing. So pretty cool. The area of growth, and this is some numbers that I think some of you may have seen from our current market outlook. And this is really one of the most exciting things in aviation that I've seen in a long time, of being able to talk about growth like this. And these are the numbers of airplanes, both single aisle and wide body aircraft, that are going to be probably going to be needed in the next 20 years. Airbus, I know you guys do a similar sort of thing, and they're amazing. The numbers come out pretty close to each other when we do this. But you can see that more than 38,000 new airplanes are going to be required over the next 20 years, and a lot of growth in Southeast Asia, as you can see there, but certainly strong growth here in North America as well as in Europe. And why is this important? Here's the same chart with the number of pilots that are going to be required over the next 20 years. Over 533,000 pilots are going to be required worldwide over the next 20 years. And again, a lot of it in Southeast Asia, but quite a few are going to be needed here in North America and Europe. Now you see this map and you see some colors on there. You see some colors, the magenta color. Those are countries, and here's the really risk that's out there for these kind of numbers. The magenta colors on there are countries that are banned by the European Union from flying into the EU. And the kind of the orange countries on there are countries that are prohibited from flying into the United States. And so we're spending a lot of time trying to get rid of those orange and magenta colors. And what we're talking about here isn't necessarily unsafe airlines. It's regulators that don't have very good capabilities or the capacity to oversee these airlines and operate a very good system. So as those of you that fly internationally, this is important to you too, because you're flying into some of these countries. So a lot of work being done by Boeing in working with these various regulators around the world, again, to try to get them all yellow like North America and much of Europe is. So those are kind of the three areas we're working on in terms of safety, efficiency, technology, and growth.
Very good. Thank you. Let's move to Airbus. And Harry, from your perspective, what's going on as far as safety with the Airbus line?
Sure. Okay. Thanks very much. We've tried quite hard not to overlap on presentations, as you will notice. I'm the token Brit, the token Limey, but it's a pleasure to be amongst you guys. This is my third year at the ALPA conference. I always enjoy your company, and I'll particularly enjoy it later on around 11 o'clock tonight, as usual. So the examination question that I was asked by Chuck was, tell us what are the safety priorities that you guys have got, and tell us, if you can, about any technological changes. So that's what I've tried to stick to. And in terms of safety priorities, I agree with almost everything Tim said this morning in his opening remarks, except perhaps for one, which is that I don't think we have gathered all the low-hanging fruit yet, especially when you look on a global basis, which we have to do inside Airbus. I think in the US, it may be more true than it is in other areas of the world. Certainly, for sure, you guys are leading the world, and the rest of the world in very many areas looks towards what you're doing and learns from that, and I think that's very important. What do I mean by low-hanging fruit? Well, I'm looking at everything from regulation, from harmonization, from the development of EBT, competency-based training. Let's get rid of dive and drive. They exist all over the world in other areas. Circling approaches, we now have the capability of replacing circling approaches. Mentoring is something we've been talking about, but are we doing it really around the world? Certainly not enough in my view. Best weather on board was mentioned at a presentation before lunch. I think it's time we had better tools for weather assessment on board. It can be done, the technology exists. I'll also look towards ourselves as manufacturers, simplifying designs. Simplifying design in the operational context, I think, is what's important. Not necessarily a simple design, but certainly its use has to be made more simple. Runway grooving in some areas where it's appropriate. And the one I'm going to touch on probably a little bit specifically today is runway condition reporting. So let me move, before I do that, I'll just talk about the others quickly. The second priority for Airbus, I think, is what we'd call finding solutions for the developing paradoxes of success. What do I mean by that? Well, the safety level that we've just been talking about. We're talking an accident statistic of 1 fatal accident every 10 million movements at the moment. The equivalent when I started flying was 64 fatal accidents for 10 million movements. But that safety level is causing us some problems and causing the industry some problems. I think there's a risk of defocusing the industry away from further improvement. There's certainly a threat to safety budgets. There's a lack of understanding, I think, across the globe in what I call the law of small numbers. I'm seeing very strong reactions to individual accidents, which may not be a trend at all. They're quite specific. Look at the reaction, if you will, to the German wings accident. For interest, I was sitting as the moderator of our safety conference when the German wings event happened. It happened on the first day of our safety conference in Paris, and I'm looking 5 rows in front of me to my left at the whole of the German wings safety team when we got the news on the top table that the accident had happened. But the reaction to it is what I want to focus on, and whether it's appropriate with regard to the overall real trends that are lying underneath. And I think there's a hell of a risk at the moment that the industry knee-jerks its reaction towards something, a solution that isn't necessarily appropriate and may even be wrong. I see that effect both in the media, with politicians, and through those two means, affecting the regulators as well. But this particular point I'm trying to make here on developing the paradoxes of success, let's bring it to an operation level. We see it with automation and manual flight. I think the debate is well joined now that we, and I don't have to defend automation because the statistics speak for themselves in terms of how much improved safety has arrived because of automation. But I think the unexpected consequences that perhaps were not expected quite so accurately were the long-term effects, like loss of manual skills and so on, which we're now trying to deal with. I put growth versus experience. Think of the numbers that Terry's just mentioned with regard to the growth of the industry, and then try and imagine how we're going to retain experience and knowledge in the industry and share that across the industry. That's a huge challenge. Another one very close to that is reliability. One engine failure every 417 years is the statistic that EasyJet came out with for their crews, based on 800 hours a year flying. I've had 7 engine failures in my career. How do you pass on that exposure experience into the real world and pass it on at instructor level? Another big challenge. These are the challenges or paradoxes of success that I was referring to. And in training, it's back to training the right things. Are we training the right things? I'll talk more about that in a minute. I noticed before lunch that the term subject matter experts came up. I find that quite interesting as a manufacturer, because when I look at how we write software as a manufacturer and how we write V&V programs for that software, the subject matter experts, are they pilots? Are they operational people? Can they ask the right questions? Do they know the right questions? How are we going to handle that dilution of experience? As it's not just in the piloting world, it's also in the design world, is what I'm saying. Okay, facing global expectations. I think Terry's touched on one of the biggest with his talk about the eco work that's huge now, and it's going on across the world. But I would also perhaps just add to that the other element which I've also included, which is the expectations of the public. They're the people that put bums on seats. They're the people that pay. And I think we have to think very hard about what the expectations are through that. And I think probably for me, one of the biggest is this matching industry capacity with the expected growth. Again, Terry touched on the growth. I won't go into that in too much depth. But I think we've got some serious issues here. In certain areas of the world particularly. Are there enough runways? Are we building enough infrastructure to contain doubling the growth in the next 20 to 30 years? If we look forward, I see a big threat here and something we should be looking at. And those are the two I'm going to focus on. So let's look at this runway condition problem for a moment, because I want to move towards the second part of my exam question, which was to do with technology. By the way, while we're talking about technology, what you guys can't see is, looking at me down here, is a clock that's ticking down, and the figures are about a foot high, and I applaud ALPA for its accuracy, because we've got hours, minutes, seconds, and tenths of a second. So catching my eye all the time is this tenth of a second clock that's rolling at a hell of a rate. So if I'm speaking too fast, guys, blame ALPA because of this clock. Okay, let's back to runway condition. We know the issues here. You're all pilots. Many of you are pilots anyway. You know the issue with runway condition. This is something that's been going on for far too long. We saw a need for an objective, timely, non-intrusive system that would actually help us solve this problem. I'm not saying, by the way, that runway reporting is necessarily bad all over the world. I know it's not. I know, for example, at Minneapolis, I'm told there are 22 different forms of sensing runway condition at Minneapolis. I guess some of you guys operate out of Minneapolis all the time. I've only been there once, but I think I know why. But that is not true for some areas of the world. I can tell you there are some areas of the world with runway condition threats where there are no sensors at all. And that might appear shocking in the US, but it's true. This is a system called Corsair that we've developed. I'm sorry about the acronym. I don't like it, but it's what it is. An engineer must have thought that up, and never a pilot. But basically, the concept here is that we use the aircraft as the sensor. It analyzes aircraft deceleration in relationship to the braking that the pilot's applying, or the auto brake system. It then delivers that. It complements the PIREP system, and it delivers it into air traffic control. So this is the way it works. Very quickly, you measure the braking through the aeroplane. You compare it with what you expect. You issue a report which is validated by the pilot. It's sent to a server. Air traffic sum that data, that new data, but very accurate data, with their other sensors, and then they feed it to the next aeroplane coming down the approach. It's not a solve all problems issue. Some of you will quickly realize that if you're the first guy in the day to be flying into this airfield, then you're really back where you were before. So nobody's trying to sell. Also, by the way, the sensor, of course, is only working over the section of the runway where the braking action takes place. So I'm not trying to say this solves all the problems. We're trying to say it's part of this iterative progress by small elements. But for sure, the data is is highly valid. It's also compatible with the ALPA work that's been done, so that the message that would be passed would be in simple pilot language and not engineering speak, okay? But we think it's a good solution. The reason why I brought it here to you guys, and by the way, there's something on this slide I just want to mention very quickly, which is that line at the bottom. I want to reassure you guys that there's no intention, nor is there any plan for using this data to assess pilot behavior or pilot performance. Absolutely not. I just wanted to make that completely clear. And the airport still remains accountable for the information on runway surface. But the reason I brought it here is because we need an industry standard on this. Airbus will not do this on its own. We don't think that's the appropriate route. We seek support, and amongst the important groups from whom we seek that support, you are one of the most important. Let's talk about training then, because it's also part of those two elements that I talked about at the beginning. We think training has to change. Training has to be modified as we move forward. The current training system has stood us pretty well, but it now needs to be updated. If I show you a new tool, I'm going to show you this tool called ACE. I've got a 2-minute 10 film here very quickly to show you.
Airbus Cockpit Experience Trainer, also called ACE, is the essential brick of the new Airbus flight training philosophy, introducing simulation at a very early stage. For pilots transitioning to the A350 XWB, the first encounter with the aircraft will be in a 3D virtual and interactive cockpit. ACE Trainer is a laptop-based training device allowing trainees to develop systems knowledge and procedures. Trainees can perform self-paced study with virtual instructor assistance.
Enter the operation frequency 17.700 and HF2.
The use of ACE eases the system's knowledge acquisition with a focus on need-to-understand lessons.
The engine has 3 rotating assemblies, each composed of a compressor, a shaft and a turbine.
Then a learning by discovering method is applied. Through guided exercises, all the entries are controlled and corrected. Trainees can practice standard operating procedures as well as abnormal procedures in a simulated crew environment. Thanks to free play simulation, trainees can strengthen their skills at their own convenience. Use ACE Trainer when, where and how you need it. ACE Trainer is also compatible with tablets. Why choose ACE Trainer? Hands-on learning from day one in a cockpit environment. Better knowledge retention. Significant time saving on higher level devices. Free play simulation for systems practice.
So now with this, you can take the A350 cockpit home with you.
Airbus Cockpit Experience. ACE by name, ACE by nature. For efficient, effective and fun training.
I think my only comment about the film is that if I'd been the chief test pilot, I would have been seen dead doing that at the end. It was a terrible final sequence. But otherwise, it's I think a film which shows you the kind of tools that are now becoming available. This tool has been used on the early 350 training and is getting rave reviews from our customers. And as a result, we've made the decision immediately that we will spread this technology across all our types, because we just see a much higher learning and retention rate through this kind of tool. The film hardly does it justice. You can work with the avatar, you can work on your own, or you can work in different hotel rooms with your co-pilot working on procedures and so. It's a very flexible tool. But it's typical of the kind of new tools that are coming on the scene now, which help learning. Let me move to another area, which is career. And some of you know already that I'm fairly passionate about this subject. I do not believe that the current training system lends itself to what I call career learning for pilots. What do I mean by that? If we take a pilot's career and break it up into 5-year spans, And if you look at this diagram at the 100% line, let represent the budget line for training for any given organization. What we currently see is a sort of ratio like this, and this is based on, it's not precise, by the way. Please don't think this is precise. It's meant to be indicative rather than precise. But for many areas of the world, what I'm seeing is a lot of checking time and not a lot of what I call training time. And the question is, as we go forward, is that good enough? Because with each year, with each new accident, we're asked to force more and more things into this training pot on top of the regulatory stuff. What I think is more appropriate is probably something looking a little bit more like this. Where we see no more than 50% of any training budget being spent on checking, and not only at the beginning, but certainly we have to have a strong investment on training at the beginning of a career. We then open up the long middle years of somebody's career to a much more learning environment. And then at the end, when you reach my kind of age, yep, a bit of senility creeps in, and we do need to keep on checking a little bit more regularly that people can still cut it. So what we're seeing then is an opportunity, and I think we recognize that behind this opportunity, there are all sorts of things that need doing better than we're doing today. If I'm talking to you and you work in airlines that are already doing this, I can assure you you're lucky, because I can tell you there are many, many airlines out there in the world which we deal with as a manufacturer that are doing the minimum. But things like advanced lofts, improving decision-making, challenging systemic scenarios, and you can read the rest. I don't have to go through it. One of the things that comes out of this discussion when I talk to a lot of pilots is that a lot of guys around the world in different places feel that when they get captaincy, they've made it. That's the top of the hill. There's nowhere else to go. I don't accept that. I believe that there is still continuous learning and a lot of other things. I'm still learning at my stage in my career. Every day I learn something new about aviation. And I think we've got to encourage that in our future pilots as well. We've got to be in this kind of environment, a fun environment, where I look forward to my training sessions because I'm going to learn something new. I'm not threatened by them. I don't feel that there's only two things that are going to happen. One, nothing changes because I pass. And two, I have a bad day and I fail and my world falls apart. I shouldn't feel threatened by training. We should be looking forward to it. We're trying to develop progressive resilience. And by that I mean being able to react to any situation by thinking the problem through and getting our thinking right rather than a specific drill right. When I'm challenged by people who say, well, yeah, but that's all very well, but you're dreaming, Harry, it won't work budget-wise, I challenge that too, because I think actually, provided we invest at the beginning, we can save budget later on in a pilot's career. And really, I kind of move on to the last 2 points on training, which are candidate selection, an underestimated area, I think. I know it is more strongly focused here in the US, but not everywhere. And finally, the quality of instruction. Think back to the growth problem, think back to the success problem. They're all linked, these problems. How are we going to maintain the very best of instructors and have that experience through exposure being passed on from generation to generation? The objective, again, is to generate resilient behavior. So with that, I'll hand over and I'll leave it at that. I hope I've stimulated some thought and I look forward to questions later. Yeah. Thank you for listening.
Thank you. Harry, always great to hear you and get some of your points. I have a couple of questions myself as a result of your presentation. I think we could kick around a little bit. So a lot of our membership, while a lot of our membership flies Boeing and Airbus aircraft, there's also a considerable percentage of our aircraft, or our membership that flies regional aircraft. And we're pleased to have Embraer here. Captain Perini, give us kind of Embraer's perspective on safety and what's coming down the road from you.
Okay, thank you, Chuck. Ladies and gentlemen, good afternoon. In behalf of Embraer, I would like to thank Airline Pilot Association, Captain Tim Cannell, ALPA President, for the opportunity for Embraer to stay here in this important event. Actually, North America is an important region, strategic region for Embraer. we have more than 70% of our fleet flying here in North America. And regarding safety, we consider that North America have a good level of safety, but good is not excellent. Taking the words of Captain Tim Cannell, always there is more to do. We have the company commitment with air safety, and this commitment involves all our factory and is extensive, arriving in our President and CEO, Frederico Curado. And our commitment with safety we have in all phases of cycle life of Embraer products, during the development, production, operation, and even during the disposal phase, when we think that you need a strong effort regarding safety during the disposal when we are flying old planes. In my presentation, I would like to highlight and there's a short view of Embraer presence around the world and show you our air safety team that we have to attend all regions around the world, some safety activities and process we have inside Embraer. And I'd like to talk about some contributing factors for accident and incident. These contributing factors mainly regarding human factors. And what we are doing in our projects, in the concept of the new Embraer aircraft, to avoid the error, the human error. Embraer, it's a global company. We start our activities in 1969. In 1949, the company was privatized. And in 2015, we have 7 sites in Brazil, United States, Portugal, France, Netherlands, Ireland, United Kingdom, Dubai, Singapore, and China. Here in the United States, we start our activities mainly with service centers. We have the biggest one in Nashville and the second in Fort Lauderdale, but nowadays we move all the production line of Embraer executive jets to Melbourne. And we are producing the ALX, the Super Tucano, we are producing in Jacksonville, this aircraft. The main Embraer business area is commercial aviation. Nowadays we are developing the new E2, new E-Jet. Executive aviation, we just launched the new products, the Legacy 450 and 500. And we flew last year, in October last year, the new Embraer cargo plane, military plane. And the base and the foundation of our services and support is safety. And in order to ensure that we have this base, this foundation, we have inside the Embraer a post-graduation course, air safety post-graduation course. And we have close to 400 air safety representatives working in all areas of Embraer to ensure that the services and the support, we have the foundation of safety. Despite of the fact that we have 100 employees working with safety, we have our dedicated personnel that stay mainly in Brazil, where you have our main headquarters. The responsible area is South America. We have the office here in the United States, the North America, under the North American responsibility. We have in Amsterdam, responsible for Africa, Middle East, and Europe. We have another office in China, Singapore, and Australia, covering practically all the world. And to talk about safety and the process, I would like to coming back and remember the hierarchy pyramid. According to the hierarchy and board theory, every 600 observed the risk situation, We have 300 recorded risk situations, 29 incidents, and 1 accident. We, as a manufacturer, we strive ourselves to avoid the accident. But if it happens, it's the moment to analyze fast and take the actions according to the safety recommendation. Inside Embraer, we issue some recommendations, and we need to be very, very fast. We understand that we need to give for you pilots, operators, quick answers. You operators continues to fly the same aircraft, sometimes the same aircraft in the same environment. And for this reason, I like to use the dollar bill symbology because it's the moment that we need to open our eyes and make it better. Improve our plane, improve the procedures, improve the training. This is our goal. When we face an accident, the aircraft crisis management plan is automatically launched inside Embraer. And according to this plan, we have 3 committees, strategic committee, media, and investigation committee to help the authorities to help the investigation authorities and to help the operators. And if you have an incident or accident inside the Embraer factory, we have the emergency response plans. We have interface with all the investigation authorities in North America. According to Embraer, it's a good interface, mainly with NTSB because you have a lot of suppliers here in the United States, and practically in all Embraer events, we have the presence of NTSB. And we used to work under Annex 13 because we are ICAO signatory. Coming back to the Harris Pyramid, in order to avoid the accident, we need to work in the base of the pyramid. And Embraer have a robust and mature process that works really in the base of this pyramid. In 2006, we received an award from Flight Safe Foundation because with this process, we really mitigate the risk. And this analysis starts with you operators when you issue a safety report from Embraer. We received this issue inside Embraer, our air safety department, and this starts a risk index calculation. It's a quantitative approach that involves all the engineering inside Embraer, test pilots, airline pilots, and we arrive in the risk index. And these risk index are submitted to the Product Safety Committee. I would like to talk later about this committee that allow us to work with the corrective actions and introduce these actions in our fleet. We have another process. It's an internal process, part of the prevention program. It's a qualitative approach, not quantitative approach. The main methodology regarding the product safety monitoring that affects you, operator, is the first one. It's a quantitative approach. And the second, it's basically focus on the product's assembly line. As I said, this process, this methodology, starts with you operators that send for Embraer the safety reports. And for this reason, it's very important to receive as soon as you have the issue, the event, we need to receive to start the risk index calculation. The risk index calculation is based on the product of severity and probability plus the level of control. And after we have the risk index, we have the validation for PSC, and we have this timetable where we have the time to accomplish, the time to define the action, after the time to make this action available for you, and the time to accomplish, to introduce the action in our fleet. Sometimes we need to ask for the certification authorities, AD, in order to ensure that all the operators will introduce this modification in their fleet. The Product Safety Committee, it's a higher company staff with practically all the areas in Embraer that is responsible for the validation and for that timetable. According to the old approach to classify, to prioritize safety issues, we have a borderline, we have a limit when we have safety concern or no safety concern. But with the new risk index methodology, all the issues is safety concern in different levels. This is the most important. We have, as a prevention program, the Embraer Operator Safety Meeting. Is the opportunity when we put together all the operators around the world to share experience regarding air safety, to complain about the aircraft, the procedures, in order to improve our product. But we have also the operators inside house visit. When mainly we used to do this visit mainly during the entry into service phase, or when we detect an increasing incidence of occurrence, increasing incidence of incidents, for example, or under operator's request. Mainly, in this case, we have a customer-oriented case of studies, lessons learned, according to the operation of this client. Talking about contributing factors, I'd like to highlight the human factors as a big proportion nowadays that cause accidents. And the new aircraft concepts that Embraer developed in our aircraft to avoid human errors. According to NTSB, this proportion is close to 20% due to personal, and 80% due to personal, and 20% is aircraft. According to Brazilian investigation authority, CENIPA, is practically the same percentage. 80% is human factors, and inside 20% aircraft, you have the maintenance. And actually, you have only 12% of the contributing factors is material factor. We, as a manufacturer, we could think that we are doing a great work, a great job. Again, take the words of Captain Tim Cannell, I just do my job. But in fact, we need to improve our products. We need to produce aircraft more friendly, more intuitive, and easier to fly. Because if it's easier to fly, it's easier to teach, it's easier to learn, and the aircraft will be safer. I'm sure that the aircraft will be safer. The aircraft equipped with systems that avoid human errors. I like the given example about the smartphones. But for you pilots, I'm not saying that you don't need to read the manuals, okay? But in fact, we need a smart system in our aircraft. This is some concept that we are using to develop our products. The first one is closed-loop full fly-by-wire controls. Is the kind of law with no matter what kind of inceptor you are using to control the aircraft. Yoke, passive side stick, active side stick. The result the result in terms of control is the same, even if you are using the guidance panel, automatic fly. And according to this law, this fly-by-wire law, the aircraft is protected in all envelope. About high level of automation, inside the control law, Embraer control law, for example, we have the automatic correction in case of engine failure of the aircraft. The aircraft only apply 5 degrees in order to have a better result in terms of aerodynamics, and in order to raise the situation awareness of the pilot during in-flight shutdown. It's an example of the importance of automation. An intuitive cockpit with a reduced workload. Regarding reduced workload, we are with a KR H with a few normal procedures and few memory items, or sometimes no memory items in our checklist. And regarding the aircraft system, the reconfiguration in case of failures. We believe that synthetic vision is fantastic for situation awareness, and all the new Embraer products we are providing with synthetic vision. And the HGS, Redapt Guidance System, is very important if we have the symbology of important systems to avoid accidents and incidents. For example, the guidance to flare the aircraft, the cue to flare the aircraft to avoid hard landing. And a kind of symbology to manage the energy of the aircraft and avoid the runway overruns. We consider that another important tool nowadays is the operational softwares and apps for tablets. I will show you that we are develop these apps inside the aircraft computer, but for aircraft that is flying nowadays, we have these tools that help, that support the pilots. Our legacy 450 and 500, you have all the high-end technology in terms of avionics inside. We supersede the requirements that came from the authorities. And we have the full fly-by-wire controls and passive side stick in this aircraft. In the new cargo airplane, Embraer plane, the KC-390T, is practically the same control laws, fly-by-wire control laws, but with active controllers. Because this aircraft flies close to the borderline of the envelope, and for this reason, we believe that side stick, active side stick, is better and safer for the operation. Regarding the new E2, the new Embraer E-Jet, this aircraft is practically a new plane with new wings, with laminar flow, new engines that save at least 60% of fuel, the same full fly-by-wire control, and improve avionics with synthetic vision, with 4 big displays where we can have 8 fields to raise the situational awareness, and with important system inside. One of the system we are developed with Boeing. The name is RS-AT, Runway Situation Awareness Tool. We have another agreements with Boeing of cooperation regarding safety, and this is one of among other programs. And in this program, we are analyzing practically all Boeing overruns incidents, the contributing factors, and all Embraer in order to provide a system to avoid the runway overruns. But you are working also in training and procedures. As a tablet solutions, we have the e-performance according the ALPA ARC recommendation. ALPA ARC recommends the in-flight assessment, and this is an important tool that we have because in few seconds the pilot can recalculate the runway length if it's sufficient with the actual situation, if it's wet, the wind, with the gross weight. And it's very important. And we have the in-flight assessment in our SLP nowadays. We recommend this in-flight assessment. And sometimes it's a redundancy, like a weight and balance. For last-minute changes, in few seconds, the pilot can recalculate the weight and balance. And it's all. This is my presentation. Thank you very much.
Well, we have to cut it at that. Please join me in thanking our panel for a very, very interesting discussion.